these things to one that you need to look forward to is the fact that as you talk about conic sections, okay, as you talk about conic sections, uh, you should expect to talk about things like the circle, okay. We should expect to talk about things like the ellipse or ellipse, depending on where you're coming from. That's how I'm going to pronounce it. Then you're going to talk about the uh, parabola. You're going to talk about the hyperbola. Okay, these are very very important. You need to take them serious. They are very very important. You're also going to talk about things like rotation of axis. So it's like everything else that might come after conic sections is just going to rotate around these. It's either you get an ellipse, you rotate it, you're talking about rotation of axis, so on and so forth. So we're going to try to understand what conic sections are in general. We're also going to try to understand what a circle is, what an ellipse is, what a parabola is. Of course, I'll not talk about everything just here now. We'll be talking about them step by step, but I also recommend to say you watch the videos that we're going to be uploading time to time so that you don't miss out on anything. So if you have any question, feel free to interrupt me. Okay. So one thing that I'm going to focus on the most in this meeting is the circle. I've not yet made the video of the circle, so it's like I'm already giving you the data that I'm going to make in the video. So it's like if you watch a video, you also hear. If you want, you still again watch the recorded session. Um, that would be a plus for you. Okay. So any question from this point before I continue? Okay, that's good. So I'll briefly talk about what a circle is. Okay. Um, or let me I'll briefly talk about what conic sections are, and we'll talk about what a circle is. Then we'll try to get some questions from some tutorial sheets. Then we try to solve and see what we are going to come up with. Okay. So now the idea of conic sections, when you're talking about conic sections, if you'd want to really understand from the definition point of view what conic sections are, um, a conic section is just more like it's I would call it more like a figure, or of course that figure is is as a result of a certain function that you're going to get, and that is from the intersection of a plane. Okay, intersection of a plane. So when I talk about a plane, it would be something like this. Okay, a plane, we know to say, of course, a plane is going to be in, is what a plane is in 3D. Okay, so intersection of a plane and a double napped cone. So double napped cone is just more something that is a bit like this. So it's more like you're going to have something here. Okay, you're going to have a cone of that kind. uh, going to have something like that. Then here we're going to have something, and we understand where all of this is coming from and why is it even important in this case. Okay, so this that we have here is a double napped cone. Okay, so here we have the upper nap. Okay, we have the upper nap here, and here we have the lower. Then at this point, at this point that we have right here, that point is called the vertex. And this word vertex, you're going to be talking about it a lot when you start talking about the parabola. That's why I'm trying my level best to pick it from the base point. And by the way, I'm unable to see if you say something through text. I'll be unable to see anything. So if you are able to like come out, like if you're able to say something like using your mic, that would do me a lot of good, because if you say something on text, I'll be unable to see it. I'm just saying, just in case. Okay, so this point that we have right here is a vertex. Then this line that we have here that I've put on the center, this is our axis. Okay, this is our axis right there. Then of course we would have an idea to say that what we have here is a vertex angle. So that would be the vertex what? Vertex angle right there. What else? Then this line here that we have this side, this is the line that is called the generator. Okay, what else do we need to know? That's all for now. So now the idea is that we have this double napped cone. So the intersection between this plane and this double napped cone is what produces conic sections, and those conic sections is either it's a circle, it's an ellipse, it's a parabola, or it's a hyperbola. Okay, so it now all depends on how the plane and the double napped cone intersect. Okay, that's how we come up with what? That's how we come up with those conic sections. In this case, we're going to talk about the circle. So now let's see what really produces the circle. So if you get this plane, okay, if we get this plane and we put it like this, we have something like that. So we have this double napped cone that we have here. Then is they're intersecting each other with a what? They're intersecting each other with a cone. So one thing that you're going to observe is that as where they intersect each other, because a cone, like it's circular in some way. Like of course it's circular on the top here, it has a certain radius, and the radius keeps on reducing as you come down here. So you observe to say at this point you're going to have where the circle, where the cone intersects with a plane, you're going to have something that's going to be like a what? That's going to be like a circle. And what makes this to be a circle? Of course, doesn't really appear to be like a circle because my sketching is not really good here. So what makes it to be a circle is because of the angle uh, at which the plane intersects the cone. So if you look at this line we say this our what? We say this our axis. So if the plane intersects the cone, and if it so happens that it's at the 90 degrees angle with the axis, it basically means what you're going to produce is a what? What you're going to produce is a what? Is a circle. So what it tells you is that as you change the angle at which the plane intersects the axis, it's either you're going to have an ellipse, you're going to have a parabola, you're going to have a hyperbola. So if you have an angle of 90 degrees, and that angle comes as a result of the intersection between the plane and the axis, if it's 90 degrees, then what you have is a what? Is a circle. Does that make sense? Okay, so that's the idea of how we get the circle. Okay, that's how we get the circle. Someone might not really ask you to say, okay, how does the circle come about? The most that someone can ask you, maybe it's a definition. I've seen definitions say define a circle, or define an ellipse, define a parabola. Even though some people would say no, there are no definitions in mathematics, please here I would advise you to know things from the basic point of view. It will do you a lot of good. Yeah, those are free marks that you don't want to lose. Imagine the definition of a circle or an ellipse is just less than 10 words, then you don't know it and it carries 3 marks, you lose 3 marks, and that would be like already 97 from the 100% of your quiz or your test, and it's gone. You're not get it back, and you also have to, you also lose some marks somewhere else. And so would like to take advantage of this. So now we have seen how we come up with a circle. So now what is really the definition of a circle? We know, everyone knows what a circle is. Like, if I were to ask my 6 year old cousin, he would tell me what a circle is. But we are talking about mathematics here. What is a circle according to mathematics? Someone say, "Oh, okay, a circle is something that is round." That is true, but we want to talk about a circle in terms of mathematics. So what a circle is, what the definition of the circle is, I'm going to give you two definitions. Okay, the first one is that a circle is just a conic section formed when the plane is perpendicular to the cone axis, which is exactly what we are showing right here. I'll say it again. A circle is a conic section formed when the plane is perpendicular to the cone axis. That's one of the definitions. Another definition of a circle is it's a set of points that are at a certain distance from the fixed point called what? Called the center. And that distance is what? That distance is called the radius. So you find that if we draw a circle like this, okay? Yes, Dorcas.
Kindly repeat the definitions.
Okay. Okay, so the first definition that I gave, maybe let me just try to uh, use some of your time and write it. So the first definition is that a circle is just a conic section, okay, a conic section formed when um, when the plane is perpendicular uh, perpendicular to the cone axis. So if when you have this plane right here being perpendicular to this cone axis, which is this center line that you have put here, that means you have a circle. Another definition that you can have is that a circle is just a set of points, okay, um, a set of points that are at a distance from a fixed point. Wait, a fixed point called the center. And that distance that we are talking about, this way that I've used here, distance, okay, that distance that we are talking about is indicated using r, which is what? The radius. Okay, so that's what I was saying. Like, if you have a circle, um, if you have a circle right here, then you have a point that we call the center. So it's just a circle is just a set of points, a set of all points, if you are to say so. So you have a point, you have infinite points. You have a point here, 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 here. So these points are at a certain distance from what? Okay, from a fixed point called the what? Called the center. So this distance that we have right here is called the what? Is called the radius, and it's the same for all of them. Even if you put another one here, it so happens to be what? It so happens to be the same. It's still the radius. That's what we mean. Is that okay there before I continue? Is that point okay? Okay, good. Okay, so now let's this might appear to be a bit boring. Now let's talk about where we bring in stuffs about the equations, so on and so forth. Okay, so one thing that is really important about the circle is the general equation. Okay, it's the general equation. So here is something for you. There is what is called the general equation. Okay, there's what is called the general equation, and there's what is called the standard equation of the circle. Don't confuse these two. We have the general equation and we have the standard equation of the circle, and they are very interesting. So the general equation is very important that we keep it dear to ourselves because we are going to use it a lot of times. There are times when they give you a set of points. Remember, we said a circle is just a set of points that are at a certain distance from a fixed point called the center. So sometimes you may be given maybe 2 or 3 points or even 4 points. Then they want you to find the equation of that circle, because that's what I was saying. If I ask my 6-year-old cousin, he'll tell me what a circle is. A circle is just something round. He's right. But again, since we're talking about mathematics, we know whether a circle is big, it's small, no matter how big or small it is, like in general, no matter what the size, it has a certain equation. Now, when you're given like a set of points, we want to utilize those points to give us that equation, the equation of that particular circle. And that equation that we have, it will give us things like the radius, it will give us things like the center, because remember to say, as you a circle is not just anywhere like in the galaxy, like it's just in the open space, you can't even know where like starting from. It's on the Cartesian plane, it's on the XY plane. So want to know where is the center. Is the center at the origin? Or if it's not at the origin, how far is it from the origin? What's the relationship between the origin, which is 0 comma 0, like 0 in the y, 0 in the x, as well as the new points that it has? And that's why the general equation is very, very, very important. If you're given a set of points, for you to know or even to sketch that circle, you have to understand how to utilize the general equation. So here is the general equation. If you have somewhere to write, I advise you to write. So the general equation is just x squared plus y squared plus dx plus ey, okay, plus f is equals to 0. Now, I know a day will come when you'll be like, wait. You, a day will come when I'll not write the general equation of a certain conic section. I'm not saying a circle. I've just said a certain conic section. I'll write that as a x squared um, plus b xy plus c y squared plus dx plus ey plus f is equals to 0. You're going to see something like this, and you might ask me to say, why didn't you put a here or b there or something like that? I can put those, but I think for the circle it's not necessary. And you understand that when you start talking about rotation of axis of conic sections. So what we have right here is a general equation of a conic section. That's the general equation. Then the standard equation of a conic section the standard equation of the circle, to be specific, is given in this form. It's r squared is equals to x minus that's x minus h squared plus y minus k squared. You might also see it written as r squared is equals to x squared plus y squared. Now, one might ask me to say, where are these equations coming from? It's very, very simple where they're coming from. So if you have a circle here, okay, and you have your center, this let's have this as our x-axis and this as our what, our y-axis. So now, since I know that a circle is a set of all points as we defined it, I'm not going to repeat the definition. What I'm going to do is that I'm going to pick something very, very, very small, like a very negligible distance, like from, when you look at this distance that we have right here, it's such that I can use Pythagoras theorem. It's like I have my x, I have my y, then what I have here is what I have here is r. And it so happens that by Pythagoras theorem, I'm going to have r squared is equals to x squared plus what, plus y squared, like that. So pick, I've tried to make this a way, way, way smaller so that I make it convenient for myself to use Pythagoras theorem. And compromising things like this is going to be more interesting when you start talking about integral calculus, I believe. Yeah, so that's where that's where this equation comes from. Now you might wonder to say, what is the h and what is the k mean? Does anyone know where the h and the k is coming from? Do we have anyone who has an idea of where the H and the K comes from? Let's talk. Anyone with any idea?
It means the center is not at the point of origin 0, comma 0.
Okay, that's good. Yeah, so like that's the main difference between this equation and this equation. The equation that you have right here, let me just get rid of this. The equation that we have right here, let me call this 1 and this as 2. So equation 1 contains equation 2. Equation 2 only contains equation 2 itself. So it's the fact that equation 1 can either be at the origin or at any other point. Okay? Then equation 2 can only be at the origin. What do we mean? Here the h, these letters that we see, h and k, so it's simply h comma what, h comma k. So if the circle is centered at the origin, meaning if the center is at the origin, meaning your h is equals to what, 0, and your k is equals to what, 0. What does this mean? If you have your y-axis and your x-axis like that, then let's say we put up a circle like that. Okay, so if this circle is centered at, if the center is at this point, and we know to say this is our y-axis and this is our x-axis and this is 0, so at this point we know to say our y is 0 and our x is 0. That's why we just prefer to use that equation there, because we know our h is 0 and our what, our k is going to be 0. So this equation we can utilize it when the center is at the origin or when it's not at the origin, but this one is only strictly when the circle is at the origin, but when the center is at the origin. But of course you're going to be told that this one you only use it when the center is not at the origin, and I still agree with that. But for me personally, I just love to use this one because I can use it any time, because even if I use it when the center is at the origin, it's still going to give me this one, because I'm going to put 0 here and 0 here and I'll still get what, x squared and y squared. Any question before I pick 2 or 3 questions that we can try to go through? Do we have any question? I'm about to open the tutorial sheet for 2023 being 2, Math 2110. So before we go to the tutorial sheet, do we have any question on anything I've talked about? Because that's all I can talk about on the SECO. The only thing that remains right now is us solving questions for this part of the SECO. Okay. So what when now that I've started solving questions, I expect a lot of participation because the part for explaining, I believe that was mine to do. But when it comes to solving questions, I would really appreciate it if we do it together. Yeah, Troy, you want to say something?
Yes, I have a question on the general equation.
Okay.
Um, is okay, I don't know if you've talked about it, but is the general equation the same as the standard equation when okay, I don't know, I'm confused about what the general equation is for. Can you explain on what it's for and where it's used? I
Okay.
don't know if you get my question.
Yes, I really get your question, and it's a good one. Okay, so if if let's say for the circle in this case, I give you 2 points, then you want to determine the equation of that particular circle. You are going to use those points, and those points are going to give you the general equation. Then from the general equation, you have to come up with a standard equation because it's on the standard equation where you know the radius, and if you know the radius, then you know how to sketch.
Okay. Yeah. Sorry.
Does that make
Could you
sense?
ask me again? Yes. Yes, I'm listening, sir.
Yeah, so I was saying, like, if I give you 2 or 3 points to determine the general equation, like, of course, questions are not really going to come out to say determine the general equation. They will just say determine the equation of the circle, hence sketch that circle. You understand? So what it is that you just have to have it in your mind to say when you're given a set of points for you to come up with it, because what you need to sketch a circle is the standard equation. You don't need the general equation, but you can get the standard equation from the general equation. How do you do it? If you are given points, 2 or 3 sets of points, use the general equation to get a like more like a general equation that is making sense. What do I mean by a general equation that is making sense? Find the value of D, find the value of E, and find the value of F. So
Yes.
those points that you're going to have, use them to find the value of D, the value of E, and the value of F. Then after that, you're going to use the equation that you're going to have to what to come up with uh,
The standard equation.
a standard equation. And how do you come up with a standard equation? Is by completing the square. So complete the square of this, then you're going to come up with the standard equation.
All right, sir. Thank you.
Sure. Okay, so this is some of the data that I have for um, so by the way, I think most of the tutorial sheets for being 2 2023, like from 1 to 9, I think starting from tutorial sheet 4, like 4, 5, 6, 7, 8, we already have the solutions. So I'll be sharing these tutorial sheets once in a while. You try to solve, then I'll be sharing the solutions afterwards. If you don't want the PDF solutions, you can still find the videos of those solutions on our YouTube channel. It's like we have a playlist for almost all the tutorial sheets. We have tutorial sheet 9 playlist, tutorial sheet 8 playlist, and the same pattern will continue for you guys. On each and every tutorial sheet that comes out, we'll give out solutions and we'll make a playlist of videos for those. Okay, so this was tutorial sheet 1, that is engineering mathematics 2022-2023. So now the first question has to do with the circle. So it's saying find the equation of the circle. Um, find the equation of the circle with center at -2, 1. Um, center is at negative 2 comma 1 and passes through the point 1 comma 3. So question 1 has a, b, c, d. So question 1 a, we will have to find the equation of the circle with its center at that. Then question b, we have to find the equation of the circle passing through those 3 points, similar to the question that Troy just is just from asking. Then c is find the center and radius of the circle passing through those points and hence sketch it. Have you seen, they didn't say find the general equation. They will not tell you that. You just have to reason to say, okay, here is the general equation that I have to use. Then we have to identify the graph of the equation, this one here, the one that you have right here. um, okay, so question 1, what do you think we are going to do there? Anyone with an idea? You are given the center at negative 2 comma 1, just write it down. Then you say it passes through the points 1 comma 3. Okay, we're told the center will indicate using c is at negative 2 comma 1. Then it passes through the point 1 comma 3. What do you think we are going to do there? We are looking for the equation of the circle, I believe. Okay, yeah, we're looking for the equation of the circle. What do you think we are going to do there? By the way, just remind ourselves in case you have forgotten, um, the standard equation is given as r is equals to, you have your x minus your h squared is equals to, not equals to but plus rather, y minus k squared. And you know to say the center is simply h comma what? H comma k. Does that give you an idea?
Yes.
Okay, how are we going to go about it?
I think since we have the center and we have one point, we can find r first, and when we find r, we can find the equation of the circle.
Okay, so what value of r are you, if you do, you have a paper with you there?
I do.
Okay, what are you getting?
I haven't calculated. Okay. 1 minute. Are we allowed to use calculators?
Yeah, you are, but come on. Yeah, okay, you are. In general, you are.
I can just ask you. I can just
Yes,
ask you.
yes, you are.
Okay.
Uh,
So three squared, that's 9. So 9, it's 9 plus 4, the square root of 13. Is that correct?
that's the value of r.
Yes.
Okay.
Is it correct?
Yeah, it is according to me. How about others? Any objections? Anyone who has found something different? Okay, yeah, that's what I've found as well. So for the others who are quiet, we simply said r squared is simply equals to, uh, since we're already given 1 point, we say x, we just pick the value of x for that point, which is a 1, minus our h, which is minus 2, so it's minus 2 squared, plus our y, which is a 3, minus our k, which is a 1 squared. So we have r squared being equals to, that is a 3 squared, giving us a 9, plus a 4 there, because you're saying 3 minus 1, that's a 2. 2 squared is a 4. So r squared is equals to 13, meaning r is equals to the square root of what? uh, Square root of 13. So it turns out that the equation of the circle is simply going to be equals to um, going to be equals to x plus that would be x plus what? X plus 2 squared plus y minus 1 squared is equals to the square root of 13. This is the equation of the circle. Any question on that one?
Will you be penalized if you expand it?
If you expand it, do you know what you're going to get?
No, I'm just asking. I'm just curious.
It's a general equation you're going to get.
Okay.
Yeah, so it's basically that it's more like we had a general equation, then we completed the square, and this is what we had. This is what we have, I mean.
Yeah.
Yeah.
Okay.
So do we have any question on the first one before I go to the next one? Okay, so the next one we are saying find the equation of the circle passing through we have 0, comma 6, we have 12, comma 2, and we have 16, comma negative 2. Okay, 0, comma 6, 12, comma 2, and 16, comma negative 2. So this is the last question that I'm doing with you on the circle. The other two, you can try them out. Try to send the solutions so that we see if we are making progress. Okay, so once again, just like our friend Troy was asking earlier, we are just going to use the general equation. So that is x squared plus y squared plus um, that is what dx plus ey plus f is equals to 0. So now the idea here is this. Maybe before I say anything, do you have anyone with an idea of what we're going to do here? How are we going to use these 3 points to come up with something reasonable? Hello? Anyone with any idea?
Uh, can I answer?
Yeah, give it a try.
Okay. Since we have 3 points, I think we can substitute for like for x, y, like three times. We'll have three equations. Then we can use like we can solve them simultaneously after that.
Okay. That is convenient. Yeah. So now let me name this as my A, this as my B, and this as my C. I loved doing this because it made my work much easier, and like so I would say, okay, for A I would do this. Since I have x as 0 and y as 6, I start substituting. This is going to be 0 squared plus 6 squared plus d multiplied by 0, which is still a 0, plus ey, our y is 6, so that will be 6e uh, plus f is equals to 0. So now you observe that this just ends up to be 36 uh, 36 plus 6e plus f. Okay, and maybe let me write it this way. Let me say minus 36 here, then I can get rid of this guy from here. Okay, then for b we have 12. So 12 squared is 144 if I'm not mistaken, plus 4 plus 12d plus 2 2e rather plus f is equals to 0. So now this one, you can observe that this is just going to be 12d uh, plus 2e plus f is equals to negative 148. Then for c, uh, c has 16. What is 16 squared? In math genius there, my brain has freezed. What is 16 squared? Is it 256? So 256 here, okay, plus that will give us 4 plus 16d minus 2e plus f is equals to what? Um, is equals to 0. Then we can simplify this. We can say it's 16, or I mean correct in the right terms, or something like that. 2 minus 2e plus f, that will be equals to is it 260 minus 260, like that. So now one thing that I observe here is that I can try to work this out in a certain way. I can get equation 1 from this one. Maybe write it in terms of f. I would say, okay, let my f be equals to um, are we there?
Yes, we are there.
Okay. Okay, let my f be equals to minus 36 minus 6e. Okay, so I'm going to bring them here and substitute in those two equations. This will have to be like 12d plus 2e, where there's f, I'll put minus 36 minus 6e is equals to minus 148. And what does this turn out to be? So this is going to be 12d. So I have like 2e minus 6e, that would be minus 4e is equals to, so I'll have like minus 148 plus 36. So that's 148 minus 148 plus 36, which is just a subtraction. That's going to be something like 112, which is a minus. Okay, so we keep this one. Now let's talk about the other one. So we have like 16d minus 2e minus 36 minus 6e is equals to minus 260. Okay, so this would be minus 16d, that would be minus 8e. So we have like 260 minus 36. This turns out to be negative 224. Have I made a mistake somewhere? Someone is trying to say someone is trying to say something. Okay, so I no longer need this. So I have like 12d minus, so as I'm working this out, try it as well, just in case I make a mistake somewhere. Okay, so it's up to us what method we can use here, isn't it? Has anyone tried to finish that up? So which one can we eliminate here? If we are to use elimination method, let's try to eliminate, I think let's try to eliminate E. Maybe it will be much easier. So if I eliminate E, I'm going to have to make this 24, then this is going to be 8, then this will be 2, 2, 4, then this has to be a minus. So 24 minus 16 is a what? It's 8, huh? So here we're going to get 8D. Here we're going to get 0, whatever, either it's plus or minus, I don't know. So even here we're still going to get a 0. So what we observe is that our D is equals to what? 0. So we can try to get our E. If we put a 0 here, we are going to get what? Is your E equals to 28? I'm getting 28 as my E.
Yes, yes, 28 is the answer.
Okay, then it so happens that for us to get our F, we have said our F was equals to minus 6 multiplied by 28, which is our E, minus 36. So we say 28 multiplied by 6 plus 36, which gives us my F, I'm getting minus 204. Are you getting the same? Are you also getting 204, negative 204 for F? I hope you are getting the same. So it simply means you are going to get x squared plus y squared. We have found that our d is 0, so we don't have a dx term. Then we have found that our e is 28, so this will be plus 28y. Then our f, we have found that is minus what? Minus 204. We can take it on the other side. That's going to be 20 what? 204. So now we can complete the square. So now this one, the x is on its own, we can leave it. So we can pair this up. So this would be like plus, open bracket, that would be y squared plus 28y, okay, 28y plus, how do we complete the square? So 28 divided by 2 is 14. So that would be like 14 squared minus 14 squared, like that, is equals to 204. So we have x squared here plus, that's going to be y plus 14 squared, like that. Then you're going to have what is 14 squared? I'm getting minus 1 6 196. That's what I'm getting, and this is equals to 204. Getting 204 there, so meaning this is just going to be x squared plus y plus 14 squared is equals to, so 196, we add it plus 204, we get 400. So this is what I get as the equation of the circle. If I've made a mistake somewhere, it might be maybe on the computations, but the whole process that we have used here is correct. Any question on that one? So now, before I say this was going to be the last question, and it is the last question. But um I have a question for you. What do you think the center of this circle is? Having seen the equation that we have gotten here, what do you think the center of the
0,
circle?
comma negative 14.
Well,
Okay. So meaning, since our center is at what, at h comma k, it simply means our h is equals to 0 because of the arrangement we have right here, and our k is equals to negative what, negative 14. So it's very simple. The reason why it's negative 14 but we have positive 14 is that it was going to be y minus k squared, but we said y minus 14 square. So that's why it became as y plus what, plus 14 square. That's why so just have to play around those concepts. If you see a plus, it was minus. If you say minus, it was positive. So that's how you use points that are given to come up with the equation of the circle. Use the standard equation. After you use the standard equation, complete the square. And one thing that I would advise you here is math 2110 or engineering math is where you apply a lot of concepts. Like when you're talking about analytic geometry, you not only stick to analytic geometry. There are some concepts from algebra, from indices, from logs, or from anywhere in math that you need to apply. So you really need to have that knowledge. Let it not scare you, but at the end of the day, guarantee you it's just like someone said, it's interesting. It's actually fun. Yeah, just give it all you got. So that's where we are going to end today. I believe the next time we are going to meet will be next week. Tomorrow I'm meeting third year students, math at 110, with something of their own as well. So please invite your friends next time, and so that at least no one is left out. And thank you very much for coming through. I will upload the class, the recorded session on the channel, just in case someone would want to go through again. You can try to check it out. I'll send the link of the video after I upload it.